problem. And again, it's all gibberish. It doesn't mean anything to me till I organize it properly. So f prime of -1 is 0. F double prime of -1 is greater than 0. F of -1 is -5. F prime of 7 is 0. F double prime of 7 is less than 0. F of 7 is 10. F double prime of 3 is 0. And F of 3 is 2. Good. I hope I copied everything correctly and I didn't look at some other problem by mistake. Now let me check. F prime of -1, F double prime of -1 greater than 0, F of -1, F prime of 7, correct. Double prime of 7, correct. F of 7, correct. And F of 3 is 2, correct. Okay, so again, do not resist this table. It's the only way to present graphs or present the work necessary for graphs. Nothing else, I'm sorry to say that, nothing else is acceptable. Okay, so I'm going to say for now -infinity to infinity. We're asked to create a function, graph a function. There are many correct answers here. Create a function that fulfills the given conditions. You can add on to them, but all conditions have to be fulfilled. Okay, so f prime of -1 is 0. Done. F double prime of -1 is positive. Done. F of -1 is -5. Done. F prime of 7, F prime of 7 is 0. Done. F double prime of 0 of 7 is negative. F of 7 is 10. Done. F double prime of 3 is 0. Done. And F of 3 is 2. So basically, that's all I need. Knowing that there is a critical number at -1, but the second derivative is positive, means that it holds water. This is a critical number. This must be a relative minimum. At 3, the second derivative is 0. So therefore, 3 comma 2, as you see, the second derivative changes sign from positive to negative. This must be an IP. And finally, I have a critical number at 7. And the second derivative indicates that the graph does not hold water, which means 7 comma 10 is a relative max. So once we have all this information summarized, it is indeed very easy to come up with a graph. So at -1, 1, 2, 3, 4, 5, this is the point. At 3, this is the point. And at 7, 4, 5, 6, 7 is 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the function holds water here. It has an inflection point at 3 comma 2. It changes concavity, and it has a maximum here. And that's my graph. Any questions on this? Good. Anything else? Is there anything else we need to work on before we continue? Anything else? Other questions? Anything else you need help with? Anyone? Okay, then in that case, we're going to continue. I'm going to share my screen. You can always stop me if there is anything that you want to go back to anytime. As you know, good. So I would like to continue now with graphing a complete rational function, a complete graph of a rational function. I'm going to start with something simple, let's say like 35. And then we're going to look at something a little bit more sophisticated. So f of x equals negative 2 over x minus 5. Okay, so can anyone give us a domain of this function? We have to get the table going from the get-go. So can anyone give us the domain of this function?
Is it negative infinity, comma to 5,
Yes,
and then 5 to infinity?
brilliant. Jess,
Sorry.
yes, perfect. Jess, thank you. So negative infinity, 0 is in the table. 5, at 5 the function is undefined. I don't have anything to write underneath, and then infinity. At this point, I know that x minus 5 will never simplify with a factor from the top. I can immediately write that x equals 5 is a vertical asymptote for sure. Okay, my next step. I have to find everything I can about the function from the function itself. Then I move on to the first derivative, and then I study the second derivative. Okay. So first of all, I have to find f of 0. Can anyone give us f of 0? Anyone? F of 0, please. Marcus, will you give us f of 0, please?
Is it negative 2 over negative 5?
Perfect. 2/5. I agree. Good. Now we want to determine this limit, this limit, this limit, this limit. Excellent. Perfect. Thank you. So limit as x approaches negative infinity from negative 2 over x minus 5, and then limit as x approaches infinity from negative 2 over x minus 5. If you remember, when we calculate limits, we have to determine the preliminary assessment. We have to find the preliminary assessment. So, what is the preliminary assessment when x approaches negative infinity? Just try it. It's okay if you're wrong. We're going to discuss this. So please contribute. It's fine if you're wrong. Quinn, would you like to help, please? What is the preliminary assessment?
When it's negative, it goes further negative.
So the numerator is negative 2. Where is the denominator going?
To infinity if it's...
You mean to negative infinity. I agree. I agree. Perfect. Now, a number divided by infinity. The sign is not important. A number divided by infinity. What will that result in?
Negative infinity.
Careful. I have a pi, or 2 pi's, because I have 2. And I want to share them with the entire population of the globe. How much will you get out of this if I divide 2 pi's by everybody on the planet?
0.
Thank you very much. So a small number divided by infinite or infinity is always 0. Perfect. So then y equals 0 is the horizontal asymptote. I go back to my table immediately and write 0. I only need the x and y, the limits left and right of the vertical asymptote. Limit as x approaches 5 from the left of negative 2 over x minus 5, and limit as x approaches 5 from the right of negative 2 over x minus 5. Excellent, thank you. Now, so let's try this. Initial assessment, what do you think? It's okay if you're wrong, please. We are discussing these things. Otherwise, if you're not wrong, then you don't need me. Oscar, what do you think? What is the preliminary assessment here? When x approaches 5 from the left.
It
The numerator is clear to be -2.
Yeah.
But what about the denominator?
it becomes negative.
So first of all, the initial assessment. You have to plug it in, right? That's this initial assessment. That's how we get. So
You get 0.
exactly. Excellent. This is exactly what happens. So now I know that this situation is either D and E or -infinity or infinity. Nothing else. Only one of these. And now we assess what it is. 5 from the left. 5 from the left. So this is 5. 5 from the left will be 4.9. 5 from the right will be 5.1. So if I plug in 4.9 here, I only need the sign. When we plug in 4.9, what is the sign of the outcome?
Negative.
Exactly. How much is negative over negative? Which of these three? Negative over negative?
It would be positive.
Infinity. Excellent. Good. Awesome. Moving on. Now, when I plug in 5 from the right, which is 5.1, what sign do I get here? So again, let me write it here as a negative. What sign do I get here? Excellent.
Positive.
Good. And now I have to choose. I have a -2 at the top and the positive at the bottom. Which one do I choose?
It would be a negative infinity.
That's it. That's all I needed. Perfect. Excellent. I'm done with the function. I exhausted everything. There is nothing else. And it cannot be 0. This fraction can never be 0. Why? Because a fraction is 0 only when the numerator is 0. And the numerator doesn't have x in it. So it cannot be 0. So a fraction is 0 only when the numerator is 0. The numerator cannot be 0, so there are no x-intercepts. So now I finish with this. Now I move on to the first derivative. So f of x equals -2 times x minus 5 to -1. Why? Why am I changing it into a product? Because there is no x at the top. If I had 2x here or x2 minus x or whatever else, no, I would have used the quotient rule. But since the numerator is just one number, I don't care to use the quotient rule. Can you? Yes. Would you get the same thing? Yes. But I think it's easier if you don't use the quotient rule when the numerator does not have x in it. It's just one constant. Okay, so then f prime of x is 2x minus 5 to -2 times the inner function prime, but the inner function prime is
1.
excellent. So now let's take a look at this. Question for you. Can this be 0? I shouldn't write it there. It's not okay. So I'm going to erase it. Can this fraction be 0? Because I need the critical numbers, right? So I have f prime of x equals 0 or f prime of x equals undefined. So is there a critical number coming from f prime of x equals 0? Yes? No? We just wrote it here. A fraction cannot be 0 unless the numerator is 0. So, any critical numbers coming from f prime of x equals 0?
No.
No. Can this function be undefined? The answer is yes. When? This function is undefined when x is?
0.
No, because 0 minus 5 is negative 5 squared is 25.
5.
Exactly, correct. But so is the function. No critical numbers then. If the derivative is undefined where the function exists, then that becomes a critical number. But the function is not defined at 5. So absolutely no critical numbers. Perfect. Now, can anyone tell us the sign of this function? Forever and ever. What is the sign of this derivative, of the first derivative? Forever and ever. No matter what you plug in, except 5, of course, because you can't. If you plug in anything in there, what is the sign of this function? Forever and ever.
Infinity.
Say it again.
Infinity.
The sign. We're not talking about symbols. The sign.
Positive?
Yes, forever and ever. No matter what you plug in, you have to square it. Since knowing that, I'm just going to do what I need to do. What does this mean about the function? If its derivative is always positive, we know that the function is always
Positive.
when the first derivative is always positive, the function is always
Increasing?
increasing. Please remember that. When the first derivative is positive, the function must be increasing at all times. I'm going to check. I don't know, I may have made mistakes, but this is how I check. If these numbers are not always increasing, I'm in trouble. Because that's what the first derivative says. Okay, so let's try. From 0 to 2/5, yes, that's correct. From 2/5 to infinity, yes, that's correct. From infinity to 0, yes, that's correct. So now my conclusion is that these two rows go in sync. They work well together. The first derivative is always positive, and obviously the numbers tell me the same story. They're telling me that the function is increasing at all times. Done. We have to look at the second derivative now. Okay, so I have the first derivative in this setup. So then the second derivative will be negative 4 times x minus 5 to negative 3. Again, I cannot forget times the inner function prime, but Jess already said that's 1. Forget it. Good. So then I have this. Now, like before, this cannot be 0. Never. And the second derivative is not undefined where the function is defined. It's undefined where the function is undefined. So nothing. Therefore, now I need to study the sign of this function. Well, this function can be positive and negative. This one was only positive. But this one can be positive and negative, so I have to be careful. So, plug in 0 and just tell me the sign. Plug in 0 here and just tell me the sign of this expression. Take a moment. Plug in 0, any number to the left of 5. Plug in 0 because it's easy. And tell me the sign of that expression, the whole thing. What will you say? What is the sign when we plug in? Correct. Excellent. 0 minus 5 is negative 5. Negative 5 to the third will be negative. Negative over negative is positive. Excellent. So therefore, if the second derivative is positive, all this piece from this to this, the function opens upward. Now let's plug in 10. Plug in 10 and tell me the sign.
Negative.
Excellent. According to this, the function has to open downward. Okay.